Hello everyone. Today we are in a lesson called electric charges and fields, and we are going to talk about a dipole. First of all, we need to know what is a dipole is. Simply, dipole is a combination of two charges. These two charges are equal in magnitude. One is a negative charge, other one is a positive charge. They are charges of equal magnitude but opposite in sign, and they are separated by a certain distance. For the sake of a reference, distance is measured from the center of the dipole. This distance is being treated like A, this distance is being treated like A. So, totally length of the dipole is being treated like 2A. But be careful that the value of that 2A is generally a small value. That's what do you mean by dipole. Now, I would like to talk about a term called axial line. Axial line is nothing but a line passing through the charges as well as the center of the dipole. If I draw a line like this line could be called something like a axial line. On this axial line, say at a point P, I want to calculate the electric field intensity. That point P must be at certain distance. Let me call the distance from the center of the dipole towards that point as some value R. Now I want to calculate the electric intensity at that point P. You know the meaning of the electric field intensity. It is nothing but the force experienced by a unit positive charge. So on this point we shall imagine a unit positive charge and we shall identify what is the force acting on that unit positive charge. On this unit positive charge, both this plus Q as well as minus Q are going to apply forces. If you look at this plus Q, this is a positive charge and this is also a positive charge. So this will be applying a repulsive force due to plus Q, and I want to identify what is that force due to plus Q, or I can call it like electric field intensity due to plus Q. You know the definition, electric field intensity is force experienced by a unit positive charge when placed in an electric field. So 1 by 4 pi epsilon naught, one charge is Q, other charge is plus 1, and I need to write the distance between these two charges. Be careful that I need to write the distance between these two charges. R is from the center, this is A, so this distance becomes automatically R minus A, right, because this is totally R and this is A, so it becomes R minus A whole square. This is nothing but according to Coulomb's inverse square law. Now this negative charge also applies a force on this, but because it is a negative charge, it is a positive charge, that is going to be attraction, that is force due to negative charge. And I want to write force or intensity due to negative charge as how much? Intensity due to negative charge of that dipole is 1 by 4 pi epsilon naught. Sign I will take later because I am already assuming the directions. By, I have to write this distance now. I know from here to here is nothing but R, here is an extra distance. So this distance is nothing but equal to R plus A. That is nothing but equal to R plus A whole square. You can notice this force due to the positive charge is acting towards right, whereas force due to the negative charge is acting towards left. And it is very clear that as this denominator is small, electric intensity due to the positive charge is more than that of the negative charge. So if I have to calculate E resultant, intensity resultant at a point P, I would like to say intensity due to the positive charge minus intensity due to the negative charge, because they are in opposite direction. I know both the values, I can write in common. 1 by 4 pi epsilon naught is common, Q is also common. What is remaining is in the first term R minus A whole square, whereas in the second term r plus a whole square. We need to simplify this equation further to get the answer. Let us simplify this equation further. So, E resultant is equal to q by 4 pi epsilon naught is common. I can write the denominator as r square minus a square whole square. The first term will be r plus a whole square minus the second term will be r minus a whole square. Let us try to simplify this equation further. So, electric field intensity on the axial line is q by 4 pi epsilon naught. This is r square plus a square plus 2ra. This is r square plus a square minus 2ra. Therefore, r square and a square will cancel. 2ra and 2ra is nothing but equal to 4ra. Am I right? R square minus a square whole square. This is the answer for E resultant. We can take this as a given result, a standard result. But say for example, if you want to make a little approximation, the very dipole is defined in such a way that the distance between the two charges is small. So, if I take that as a condition, what is the condition I am taking is the point P on the axial line is much bigger than that of A. Then I can say r square is much bigger than that of a square, and a square that is there in the denominator can be now further ignored. So, electric field intensity on the axial line will become, it is now approximate because I am ignoring something, 1 by 4 pi epsilon naught, q is there, 4ra is there. I will ignore that r a square now, r square whole square. It is r power 4. So, 1 r can be cancelled, 1 by 4 pi epsilon naught q into 4a by r cube. This is the answer that what I want to express or else derive is. Anyway, there is a term called electric dipole moment. What is that electric dipole moment is defined as product of any one charge and the distance between the charges, who is a vector whose direction is from minus q to plus q. It is shown with a term P. So, I can rewrite E axial line as 1 by 4 pi epsilon naught 2 into 2a into q by r cube. So, I can rewrite my equation as 1 by 4 pi epsilon naught 2p by r cube is the regular equation that people consider for the electric intensity on the axial line of a dipole. Thank you. I want you to come back and see the website as well as the YouTube for the further videos and learning physics in a comfortable way. Thank you.